On this first problem, we're going to do the state, plan, do, conclude procedure to construct a 95% confidence interval. So the state step, we want to state what we're trying to do in this problem. So in this problem, we want to construct a 95% confidence interval for the true mean red blood cell count of adults. All right, so that's what we want to do. The next step is our plan. In the plan step, I like to include the inference method as well as the conditions. So we'll say, we will use a one sample Z interval. And we can use this because the population standard deviation is known. So let's see, we will use a one sample Z interval because sigma is known if the following conditions are met. So the first condition is random. And in the problem, they tell us it's a simple random sample of 50 adults. So our random sample is met. Next, normal. We don't know if the population is normally distributed, but since our sample size is 50, which is greater than or equal to 30, the central limit theorem applies, and it says the sampling distribution is approximately normal. And then finally, independent. Because we are sampling these 50 adults without replacement, it's important that they don't represent more than 10% of the population size. So there are far more than 500 adults, so the 10% condition is met. All right, next the do step. So in the do step, we can start by writing the interval, or how we're going to construct the interval, which is we'll take our sample mean and we'll add and subtract a margin of error, which is Z star times sigma over the square root of n. So if I fill in all these values, we know we had a sample mean of 4.93 or 4.63. Plus or minus, to get Z star, we can do inverse norm 0.975. And the reason we don't put 9.5 in here is because inverse norm works like this. If we want to find the cutoff values to cut off the middle 95% of the normal distribution, that would leave 2.5% here and 2.5% here. So when we do inverse norm of 0.975, we're telling it to find this cutoff value right here, which includes both the 0.025 in the tail here and the 0.95. So anyways, if we do that, we get our Z star. It's 1.96 approximately. And we know the population standard deviation is 0.54. And our sample size was 50. Now, rather than actually doing all this math, I'm going to go on my calculator and push the stat button. And if you scroll over to test, one of your options is a z-interval. And if you click the stats button here, you could say, all right, the population standard deviation is 0.54. Our sample mean is 4.63. And our sample size is 50. And we want a 95% confidence interval. And there's our interval right there. So I'm going to say this yields this interval, 4.4803 and 4.7797. All right, with that, we'll go to the conclude step. We are 95% confident that the true mean red blood cell count of all adults is between 4.4803 and 4.7797. And with that, we're done.